Hello, this is Behraf Bahrami with my group mates Unique Bakrul and Saran Sharmal from Lamar University Department of Civil and Environmental Engineering. We are working on a project of remote sensing course regarding the unsupervised classification of land cover in Jefferson County during 1984 to 2023. I'm gonna start with some brief introduction about Landsat data, which we used for our remote sensing techniques and land cover classification. As you can see, they are consist of 11 bands, which according to our objective, and since band 1 to band 7 essentially provide us a more precise data regarding our land use and land cover study, which is related to vegetations and urban development and stuff like that. We use just band 1 and band 2 band 7, which is sufficient for us. As you can see, depending to the objective analysis and physical properties that bands are sensitive to, we can use and select the specific band which would be sensitive to and would be beneficial for us. So since, as I told you, are looking for changes in land cover, which are mostly vegetations and urban developments, and also the other kind of land covers over Jefferson County. We use band 1 to band 7, and band 8 to band 11 are for more studies. Our case study would be Jefferson County, located in southeastern Texas, and with the area of 1,113 square miles. And we looked for changes during 1984 to 2023. Our methodology started with data gathering, going through the pre-processing using QGIS and R. We used some R scripts and used RStudio as well. So we did principal component analysis, and we achieved principal PCA loadings. We used that PCA loadings as the input for the order and the function for unsupervised classification thing. We used k-mean clustering using that R code, and also we try to match the clustered images with the MRLC, which is our reference land cover map, to determine how much our clusters are close to that MRLC, and to identify which which number of the clusters would be enough, which one is the best match. And after that, we identify the ground control points or GCPs of the cluster images using that site, which is MRLC. And after that, we went through the HC analysis. After HC analysis, we started comparison of 4 decades of clustered images, and actually visually analyze them to identify the changes over 4 decades. How, for example, vegetation was growing during a whole decades, or the urban area have been developed, or stuff like that. And after that, we used QGIS to calculate the area under every land cover to get more precise and accurate results for this comparison. We started with the data gathering. I downloaded the shapefile from the text.opendata portal. Since we wanted to use the USGS Earth Explorer, we are not allowed to upload the shapefile, so I expanded it to have a more extended area of study to get more precise and more accurate images of the landsets. So and I made a zip file and uploaded to that zip file of the shapefiles, and I uploaded to Earth Explorer. For the date range selections, initially we was planning to comparing two data sets calling dry and wet, and so that we used a prism website to download the monthly average precipitation data, and we wanted to do the project twice for dry and wet periods and compare them to see how these area study have been changed during this duration, both for dry and wet seasons. But since we were out of time, so we decided to use just dry data. And also we used a Landsat C2 analysis ready data from USGS Earth Explorer, and we try to minimize the cloud coverage to actually avoid any misleading during the clustering. And also we encountered with some problem calling a scan line corrector, and we try to avoid that kind of images which are being interrupted with this scan line zigzag lines on the Landsat images. So we gathered data like this. We use some steps in QGIS to mosaic the all bands. We have four tiles for each Landsat data. We have four tiles for each date. So finally, we have to mosaic 25 bands for each decade. So we used SPC plugin in QGIS, and also we used SPC plugin in QGIS for clipping these all bands. So we had the clipped version of these bands for each decade finally. And also we always have had a look to CRS, and we got ensured that it is has been set to Albert's AEA WGS84. We conducted some EDA, which means exploratory data analysis using R on 7 clip bands, and we also have uploaded the Jefferson County GPKG file, and also this exploratory analysis ended up in some box plots, in some histograms showing how changes has happened during these 4 decades, and also some correlations between different bands. And also we did contrast assessment, and also we calculated the correlation and watched how this contrast enhancement affect this correlation between these different bands. My friend Saranj will come after me.
Hello everyone, this is Miss Arans. So okay, and the graph you see is like this is the box plot. Each of the Landsat is a you can see the median in every box, which was the black line is like is the box plot over here, and you can what we try to do is like with that data we try to create a box plot to find out is there any outlier or not, and we see this is the box plot of like the 4 decades, and we see some all of the data are not similar because we can see all the bands are in the different ranges, and which shows us like there might be some different range. So what we did for this is like we tried to omit the outlier, and then after omitting the outlier we try to plot the histogram. We try to plot an histogram. We see like there are some uniformity in each different decades. So now talking about the contrast enhancement function, we can see like the pre-contrast enhancement represents the data that we took initially from the Landsat, and we tried some contrast enhancement feature in the R code and get some data, and to know the exact difference, like how the data is the data is totally different or similar, we try to create a correlation plot in which we found out that the correlation is similar, so which indicates us that the data that we took was analysis ready data. So it somehow like tries to tell us that the data are of the good quality. And after that we did the PCA analysis, which give us the values from the PC1 to PC7, which shows the variance of every uh, variance of all the data. And over here the one which you are seeing is the PCA loading. We want to notice that is there any changes, does the data that we are getting trying to tell us something or not. So we try to see the components loading, which give us all the bands with the all PC1 to PC7 data. And you can see like all of the datas are like not similar, it is somehow different than each other, which indicates us there might be like some environmental changes as the decade pass by, because the data that we are taking is like from the different decades, so it shows there might be some environmental changes. Yeah, and we can see the data from the land use classification too. So over here, while doing the k-means cluster, we try to optimize the number of cluster that we can use. You can see the on the top, you can see we use like 4 clusters, 5, 6 and 7. We want to find out like what would be the optimized cluster number. So when we go for the 4 cluster, you can see the image like the forest and the water area is kind of cover the whole Jefferson County. And when we use the 6 and 7, it shows like you can see in the water area the land portion is like touching is like blocking the waterways. So to know exactly how what number of cluster we should optimize, we also use the MRLC data. The lower picture which you are seeing is the MRLC data, which tell us the ground truth data. And looking into it, what we did, we used it in the QGIS and tried to process it. And we used that the CSV file into the QGIS and try to compare the data with what we could optimize. So with the 5 number of clusters, it kind of give us the like somehow a good data, and we went for these number of clusters. And so as you can see in the 4 clusters, it cannot capture all the relevant segments. And so we decided, so as 6 and 7, so we decided to go with the five clusters. And for this so with the MRLC data, we tried to find out what does the data mean. So we found like water, developed woody wetland, hay and cultivated, and which we tried to get see what our the clusters data that we get what represents. We want to know like whether the data that we are going is like relevant to that or not. So to find out, with the help of the QGIS, we found out like it represent the similar data as so using the ground control points. So it shows us like the data that we're getting are like somehow similar to it. And apart from the k-means cluster, we also tried to use the hierarchical cluster analysis. So with this cluster analysis, we also tried to use the five cluster, but since the data is too big, so our due to the memory allocation problem, we cannot get the we cannot get the data. So what we did is we tried to simplify the data. We use the only around 2% of the data, whole data, and with uh, and with that CSV file we tried to plot into the QGIS, and we came up that only the cluster 1 was like huge. So so we turn it off and try to find out like the other cluster data. So it shows so you can see the picture over here. And which also kind of noticed that due to some kind of problem memory allocation, which we cannot change right now. So when we compare the data that we get from HCA analysis and k-means, we prefer to go with the k-means. So from this onward, my friend Unique gonna describe you the further part of the project.
Hi everyone, I'm Unique Bakrel. I'll be continuing with the remaining of the slides. So talking about transition matrix, we have 3 tables which show the transition matrices in Jefferson County. The first one shows the transition from decade 1 to 2, the second one decade 2 to 3, the third one from decade 3 to 4. Looking into the transition matrix, what we can say is the woody wetland remain unchanged the most in forests. transition, and from 1 to 2, which is 143 square miles. The numbers represented in these tables are all in square miles. So what we can say that is water, cultivated land, and woody wetland remain almost unchanged, with around 122, 137, and 143 square miles of area remaining unchanged approximately. Talking about the changes, develop 87 square miles of hay was converted to cultivated land, which was the highest change which could be seen in this, whereas 78 square miles of hay were converted back to woodland, which was also a significant change. Similarly, in looking into second transition matrix, similar trend of having highest unchanged area of water, cultivated land, and woody wetland respectively. Looking into the changed land use, 123 square miles of cultivated land was changed to hay, whereas 89 square miles of developed land was changed to cultivated land. And looking into the fourth matrix, we could see the unchanged four different land covers with high unchanged, that is water, hay, cultivated land, and woody land having high unchanged area, whereas only 59 square miles of developed land had unchanged area. Talking about the changes, 111 square miles of hay was converted to cultivated land, and 103 square miles of hay was woody wetlands was converted to hay. It is probably due to the deforestation in the area. So after we did our K-means clustering, we had obtained four different clusters for four different decades. The first one represents the first decade, second one second, third, and fourth similarly. So looking into comparing the first and second decade, what we can see is the area remained almost unchanged, but slight increase in the cultivated lands in the western ages. The area of water remained changed, and the cultivated land area also increased in the topmost part, with the high frequency of black patches comparing to first one. The massive increase which we could see was increase in developed land in center part, and increase of development in the uh, northeast part of the Jefferson County. The area of hay seems to be similar. Looking into D2 and D3, the area of water seems similar, but a massive change that we could see was uh, the removal of urban land from central regions. It could be probably due to the removal of temporary construction constructed during the second decade. Another important changes that we could see was in the southern regions or coastal regions. A lot of hay areas were converted back to woody wetlands in decade 3. But looking into the fourth decade, the woody wetland areas, which is basically vegetation, were seen as cultivated lands. In decade 4, the area of water remaining almost the same, and increased cultivation in the along the west coast of the area. Comparing the first and fourth decade, what we could see was uh, area of water was slightly increased. It is probably due to the improved irrigation system in the fourth decade. The area of woody wetlands or vegetation remain slightly decreased, whereas there is significant increase in cultivation along the southwest part and west part of the area. And we could also see some increment in the developed land between these decades as well. Talking about land cover changes in this area, in decade 1, hay was highest land cover with around 29%, followed by 26%. But looking into decade 2, woody wetland, where woody wetland and cultivated had roughly similar land area. But in decade 3, hay had high 28% of the area, and similarly in decade 4, 32% of the entire area of Jefferson County were hay. From this, what we can conclude is the area of water was almost the same. Uh, in case of developed land, we could see a spike in second decade, but it went back to normal in third decade, the area of cultivated land. So it's similar pattern with 26% in the first decade, which was still 26% in the last decade. The hay area slightly increased, whereas woody wetlands slightly decreased. We made some assumptions in doing this project. Some of those assumptions were selected images with the least possible cloud coverage were taken, and we assumed that these least coverage having even small proportion of cloud didn't interfere with the data. We also excluded the SLC of Landsat images from consideration. In this project, initially we tried to analyze the dataset periods with the least dry and most wet precipitation, as well as the average precipitation as well, but due to the time constraint only dry periods data were analyzed. And for area calculations, in the grids that we created, the land cover type occupying the largest area was assigned the entire grid area, which might have created some errors while classifying the land covers. These are the references we used. Thank you.